excited about what's happening in the electric vehicle market today. Gasoline-powered cars are going to be a thing of the past. They just have to be. Number one, they're just not very efficient. And number two, they have a lot of problems with emissions. So if we can convert over to an electric vehicle framework as opposed to standard gas cars, that's going to do a lot for our society to make things better. We're off right now traveling to the electric vehicle team for Southern Polytechnic State University. They're going to show us their vehicle today. And in fact, they've got 3 vehicles to show us. We've got an electric truck that they've converted from a gas truck. They have an electric go-kart that they've been using for competitions. And they also have a electric motorcycle, which they've taken to raceways. So this is going to be a really interesting show, so make sure to stay tuned as we go and take a look at the electric vehicle team. All right, before we get started, we're going to need to learn a little bit about electric vehicles and how they work. Now, electric vehicles represent the future of transportation in this country, and there's a lot of reasons for that. The first reason is they're incredibly simple. Basically, there are 4 main components in an electric vehicle, and we're going to go over those in a minute with my assistant. Having so few components means that it's also going to be very easy to maintain. If you open the engine compartment of your current car and you look inside, it's going to be this vast array of complex systems, many of them for emission controls, etc., etc. And none of that is going to exist in an electric vehicle because it doesn't have an emission. It doesn't have a tailpipe. There are no gases being emitted. So it's incredibly efficient, and also the running of the vehicle itself doesn't pollute the environment. Electric vehicles also have an advantage in efficiency. They are incredibly efficient from taking energy in the battery and driving the car along the road. Take, for example, Tesla's new Model S. It's 88% efficient at taking the energy stored in a battery and driving the car. Now, in a conventional car with a gas-powered engine, the best efficiencies that you could possibly hope for would be about 35%. Now, that's because most of that energy is inefficiently burned off and as heat from the engine compartment itself. So you lose all kinds of energy when you go that route. Another advantage of the electric vehicle that I really love is the instant torque conversion the motors give you. Whoa, torque conversion, what the heck is that? Well, what that basically means is how fast you can come from a standstill to driving the car. So it has great acceleration. Electric vehicles have an amazing acceleration, and that's one of the things we're going to see a little bit today. Now, before we get started, I'm going to get the assistant to come out and give us a hand. Are you ready? Awesome. Okay, good. Now, what we're going to do first is we're going to take a look at the main component that most everybody's aware of. That main component is going to be the electric motor. Now, the electric motor is what drives the wheels or the transmission, depending on how your car is configured. And the electric motor is one of the most important parts of the vehicle. Tied to the electric motor, though, is another very important piece of electronics called the motor controller. The motor controller actually drives the motor and makes it go at certain speeds appropriate for what you're doing. It helps you control the speed and control the power that's being delivered to the wheels. The motor itself needs power, so the batteries are then connected to the motor controller, which drives the motor. You see the picture here? Batteries, motor controller, motor, that's it. Now there's one little piece that's missing because that little piece can either be in the car or external to the car. That is the charge controller. We've got to have some way to get the power and energy into the batteries, and we can do that by having a charge controller mounted in the vehicle and then having a plug come out of the vehicle that you can plug into the wall. Or we can have the charge controller outside the vehicle and you just connect up a connector right to the batteries. Depends on the manufacturer and what they want to do with their system as to how they configure it. Now the vehicles we see today are going to have a variety of different configurations, and we're going to point those out as we go along. So let's get back to the show. Hey guys! Okay, we're here now with Jason McGahey. He is the president of the electric vehicle team here at Southern Polytechnic State University, and he's showing us the electric vehicle that they created from an old Chevy S10 body. You want to tell us a little bit about the vehicle, Jason, and what's going on in here?
Sure. Well, we started with a Chevy S10 that had the motor blow up on it, so we got it for cheap. We ripped out all the internal combustion parts that we would no longer need, so radiator, gas tank, and the motor itself, all gone. And then what we did was we built a rack for our battery bank to sit the batteries in here. We got 5 in here and 7 in the back. We got an electric motor that we hooked straight up to the transmission. We have our motor controller over here, our throttle, which sends the signal to the controller, and this is a 12-volt accessory battery to control lights and other 12-volt stuff that the truck needs to run.
All right, fantastic. So basically this has all the elements that we've talked about that need to be in an electric vehicle. We've got our batteries, our motor controller, our electric motor. Okay, so let's go around to the back and see what's going on back there. Back here you have another bank of batteries. So you wanted more batteries because why? You wanted more range and power? Or?
More range and a higher voltage. The voltage will really determine the speed that the truck can get up to.
Okay.
So with 12 batteries in total,
right,
at 12 volts each, that's 144 volts.
Okay.
It gives us a speed of around 60 miles per hour.
Wonderful. So this thing can really compete on the regular road, drive around with all the other traffic, no
Sure.
trouble. Okay. Now, what is this thing unit here for?
This is the charger for the batteries. We
Okay.
built it right into the truck so that we wouldn't have to worry about finding a charger.
Okay.
All we got to do is find a place where we can plug in.
Oh yeah, let's
We
come.
put our plug right in here where the gas filler would normally be, and so we just pull our
So you
cord
just
out.
plug that, you take that, you pull it next to an outlet in the garage, and you just plug it in and it
Sure.
charges. How long does it take to charge this thing?
Well, this is
to get-
a 120 volt connector,
Right?
so it takes about 8 to 10 hours to get a full charge
Okay.
on it.
Okay, so that's not too bad. You come home, you plug it in, charge it up, and then you can leave for the next day. Now I know this is kind of a retrofit for you. This vehicle was not designed as an electric vehicle from the ground up. It was a gas-powered vehicle. So you've stuck a motor in there, an electric motor where the engine is, and it drives the transmission, right?
Right.
Okay, so you're not going to get as much efficiency as, say, an electric vehicle designed from scratch.
That's true.
So how far can you go on a charge in here?
Well, with these batteries, we can get about a 40-mile range.
Okay, that's not bad for a retrofit like this.
With better batteries, you can extend that range, but then you also increase your cost.
Okay. Hey, let's head out on the road. Is that okay? We can take
Sure,
it for a
let's go for a
drive?
ride.
Let's do that. All right, so let's head on the road and take a look. Sitting here now, we're in the car. What is it you have to do to get this thing to go?
Well, we have 2 key systems. One, the regular key to unlock the steering wheel,
Okay.
and this key
To turn
activates
on
the electrical motor.
Okay. So right now it's active. You've turned them on.
Right, we got voltage over here.
Okay. So, all right.
And then we just put it into gear,
Okay.
and we step on the throttle.
Okay.
Oh,
We
pull
take
the
off the
parking
parking
brake.
brake off. There you go.
Yeah.
Hey, it works just like a regular car.
and we got a little squealing that happens as you just start to take off.
Right,
And that goes
right.
away as soon as we get rolling.
Fantastic. It's a nice smooth feel. There's no real loud engine noise.
Right?
That's kind of strange, I guess, right? If you're driving around, you don't hear the normal noise. And now notice you're shifting unusually different than what I would normally shift. There's no clutch in here. So the way this had to be built, you are doing what to shift gears,
Well, the 5-speed transmission is still in place,
right?
but because the electric motor doesn't have to keep revs up,
Right?
there's no need for a clutch. You can just put it directly into gear and then when you're ready to switch gears, you just throw it into the next gear.
How do you know when it's getting low? How do you know when you're about to run out?
Well, you don't want to run the batteries down to 0.
Okay.
So with a 144 volt system, we really don't want to get down to below 70 volts before
Okay.
you get a recharge on it.
All right. So you watch it, and then when it gets down to close to 70, you decide it's time to call it quits.
Absolutely.
All right, and carry it in. So and you're saying that takes what, 20 miles or so before it gets to
Yes.
that point? That's good. That's a good commute home. So that would carry you home fairly easily. I like that. Hey, you know, why don't we just skip this and go get some donuts? What do you think?
Well, we got some donuts lined up later.
All right.
We have about $3,000 into this project.
That's all?
That's it.
That's it. So you converted this old S10 into an electric vehicle with about $3,000. That's not
And
bad.
that includes the price of the S10.
Oh, really?
Yes.
So how much did the S10 set you back?
Oh, about $500.
Okay.
Because it had,
Okay,
trash engine.
so there you go. I mean, if you want a car that's going to be all electric, you have an option for $3,000. You can create an Chevy S10 electric car.
Sure can.
Thanks. All right, hey, let's go take a look at that go-kart. I've had my eye on that.
All right.
Okay. All right, now we're here with Matthew Lawrence. And now Matthew Lawrence is the go-kart team lead, and basically you're in charge of the electric go-kart. So we just got through riding and seeing the electric Chevy S10. Now we've gone down to the go-kart size. Can you tell us a little bit about how this works? What are the different components inside the electric go-kart?
All right, we're running a DC permanent magnet motor. It has a peak horsepower of about 19.1. We're running an Ultrax controller that's open source. It's free to use there.
Really? That's
Software.
great.
Yeah.
Okay, that's great.
We're running the batteries. We're running lithium iron phosphate batteries. Each
And-
cell, we're running 16 cells, and each is about 3.2 volts.
Okay, fantastic. So why did you choose that type of battery?
These batteries, they have a very high capacity rating.
Okay.
The cells here are about 100 amp hours.
Okay, fantastic. So that gives you a chance to put this in a race and go for a long time. Is that right?
Exactly. We're able to go about 12 miles. Our race was a 50-lap race.
So you went in a race. You went. Where did this race occur?
It was in Indianapolis, the IMS Motor Speedway.
Okay, Indianapolis. That's fantastic. So it was a 50-lap run. What happened?
We ended up getting 6th place
Wow,
and 2nd place overall in efficiency. So we were really proud about that.
that is fantastic. So how many people were competing in the field?
In our bracket, we were racing against, I think, 11 other teams.
Okay.
But overall, there was 34 teams there.
Oh, that's fantastic. That's fantastic. So it's very low to the ground. That's one of the things I'm noticing here.
Yes, you
Did-
want it to be low to have that good center of gravity to hit those curves, right?
All right. And so has that caused you any problems being so low? It almost like you're riding on gravel.
Yeah, sometimes, riding around on campus, we can feel the
Right.
scratches, but on a track, it's going to be smooth.
Okay.
So we don't feel anything right there.
Oh, that's fantastic. So this is very similar to the Chevy S10 that we just saw. Basically the same components. We have the battery power, we have a motor that drives the wheels, and then we have a controller that controls everything, controls the motor, and then there's probably a charging system somewhere. Where would that be?
Our charging system is actually totally off the unit. We lift up our cases
Okay.
and we just pop them in each for each.
So you
floor.
pull the batteries out and you charge them and then you put them back in?
We don't actually pull them out anymore.
Okay.
We made our own wiring harness. So
Okay.
We just put it on top and then just.
You charge it in the vehicle, but you bring it to the car.
Exactly.
Is one complete charge enough to get you through the whole race?
Yeah, it is.
That's fantastic. 50 laps?
50 laps.
That is
That's
fantastic.
about 12.6, 12.8 miles.
Well, that's really cool. It'd be probably pretty cool to see this thing in action. So do you think you could show us
Yeah.
how it goes?
No problem.
All right, yeah, let's see it. All right. Wow. Holy cow. Woo. Whoa, nice. That's electric power, folks. Electric power. There's nothing wimpy about electric. That's, had you rather drive a gas go-kart or an electric go-kart?
Definitely electric.
Definitely electric. That is fantastic. So they're actually going to let me drive this thing. That's amazing because they just don't know how bad a driver I am. But they've already committed, so you can't take it back. So it works like a regular car, right?
Yeah, pretty much. Just need to turn it on right between your legs.
Turn it on. Okay. Whoa, hello, whoa, boy, whoa. Wow. Amazing, this is amazing. This thing has amazing acceleration. And I also think the best way to brake on this thing is actually to turn. So if I make a sharp turn, that's how to slow it down. I won't do that now. Ready? Woo! I am loving this electric vehicle. This thing has amazing response. I've ridden in go-karts before, gas powered, they've got nothing on this. Super right off the line power. Oh, so if you guys need me for the next competition, I'm ready. One last thing we want to look at though. We've seen the go-kart, we've seen the electric vehicle. Let's go take a look. They've actually created an electric motorcycle. And so let's go talk to the motorcycle driver and take a look at the vehicle itself in here. All right, we're here with the electric vehicle team's electric motorcycle division. Now basically, these guys race an electric motorcycle. Right here with me is the team lead. This is Tyler, and this is Caesar, our veteran motorcycle racing driver. Now this vehicle you guys recently carried to competition, am I right?
Correct.
Okay. How did we do? What happened with the vehicle when you carried this to competition?
Oh, well, we took it to Indianapolis Motor Speedway for the FIM E-Road Racing Series, which is a strictly electric series of motorcycle racing. The bike performed very well on the track. We were competitive with the Zero Motorcycles, which is a production team based in California that build those bikes for a living. And so
y'all built this from
Correct.
Scratch, right?
Yeah, we were the only university team and prototype team at the competition.
The only
Correct.
university
Yeah,
team.
yeah.
That's fantastic.
Virginia Tech was supposed to show up. They weren't able to make it, so that left us being the only university team against factory production teams that
Right.
have their big facilities, R&D time, money to back them. And
That's fantastic.
this is a prototype bike that we raced against them. So we were very competitive with the Zero bikes.
Okay.
Bramo was essentially in another category themselves. I mean, their bikes are
Okay. So
super
you had a
nice.
wide range of things. We were the only university team to compete
Correct.
there.
Yeah.
You were the driver during this competition, right?
Yes, I was. I'm also a student here at Southern Polytechnic. I'm a mechanical engineering technology student, but I also happen to be a veteran racer. I've raced AMA Pro for 12 years and also raced a Weir for the last 15, almost 20 years actually.
That's fantastic. So we have a veteran professional race driver carrying our electric motorcycle into the competition. All right, now I heard some interesting rumors that this bike actually was able to break 100 miles an hour. Is that true?
Actually, this bike broke 160 miles an hour on the dyno.
Wow, that's fantastic. 160 miles an hour. I can't even fathom going that fast. Now, you're a competitive motorcycle racer. You've probably raced gas engines before this quite a bit, right?
Absolutely. This particular bike started as a gas-powered bike. It's a KR250 that I had shipped over from Ireland. It raced in a European Cup Series, and we just took out the 250cc two-stroke gas engine and replaced it with electric powertrain components.
Okay, fantastic. So how is this the first time you've raced electric motorcycles?
Absolutely. It was
Okay.
quite an experience. Particularly racing gasoline bikes, for a long time you have reference markers like your RPM, engine RPMs and shifting,
Right.
whereas you don't have that with this.
So you don't do any shifting.
None at all. It's just all.
So how do you just all go?
It's all go. You're relying on your instincts to determine how fast you're approaching a corner, when to brake, when to tip the bike in, when to roll on the, I guess the throttle, you would say.
So you've had the taste of both. Which do you like better?
I think it's 6 of one, half dozen of the other. I'm just really, this is a new experience for me with these electric bikes, and it's fascinating because on the one hand, you don't have the reference points of shifting and RPM. On the other hand, you don't have the distraction of shifting and RPM.
That's true. That's true. You focus only on the track and the race.
Only on your perspective of speed to determine when to brake and where to accelerate.
So what's this display do up here for you?
That is the, it's called the Cycle Analyst. It's
Okay.
a popular used gauge by a lot of e-bike riders, the e-bicycle riders. It basically gives you real-time voltage, amperage pulled, watt hours per mile, so you can actually
Okay.
calculate, what kind of efficiency you're getting. Gives you a kind of like a gas tank feature of how many volts you have left to use
Okay.
with the battery. So it's a great all-around gauge. Speed, calculates the speed, real-time speed. Great gauge for electric vehicles in general. No matter if it's on a bike, a car,
Right,
it's just an
right.
all-around great gauge to use for electric vehicles.
That's fantastic.
Right.
Now, we've mentioned before, I've talked to you guys before a little bit about how these different vehicles work. Where is the motor in
The
here?
motor is actually right here.
Okay.
This is an AC20 induction motor.
Okay.
I think we cranked 68 horsepower out of this motor, 110 foot-pounds
Wow.
from 0 RPM. So instantly you've got
Instant.
peak torque.
Oh,
right?
yeah, instant
And-
torque. That's what I've always heard.
Right, and the torque, extends out through the RPM range and drops steadily. So this is an AC induction motor. Now the controller is actually mounted below him,
Okay.
right below there, and the controller has over 100 parameters that you can actually change.
Okay.
Dial in. You can read real-time data from the controller, motor temp, controller temp, voltage, amps, everything from that controller.
Oh, that's
you can
fantastic.
read
So
out
it
from the
provides you
laptop.
with all the status and data information that you need.
Right.
And then where is the battery?
The battery pack fits underneath this. This is a fake gas
Oh,
tank.
okay.
Per
Fake
se.
gas tank. All right.
So it's fiberglass. It's hollow. So we wanted to capitalize on that space that we weren't using for
Right,
gas.
right.
And this is actually the battery pack right here. It's out for testing at the moment.
Okay.
So
So,
these are lithium polymer chemistry cells.
all right.
Each cell fully charged is 4.2 volts and 5 amp hour.
Oh,
So
fantastic.
this cell
That's a lot
alone-
of power in just one cell.
Correct. They're the most powered in cells you can really get on the market. Each cell can dump 100 amps continuously without breaking a sweat.
Wow.
So very powerful cells.
And you've got how many of them?
We've got 360 total.
So this is one half of
This
the
is-
battery pack.
Correct. This is one part of the battery pack.
Wow,
Yeah.
that's fantastic. So how do you charge this bad boy? It must take quite a bit to charge that.
Right. Well, we were using a Variac, so that we rectified, and we're able to charge it. I believe it was 40 amps total.
Okay.
That was the bulk charging aspect of it, and we also had balance leads to each module that we could actually charge and balance with this smaller RC powered charger.
Okay,
So we
fantastic.
bulk charge, and then we balance later with this, and so all
So
around.
what you mean by balance is you've got to make sure each cell
Correct.
is charged at the same level, otherwise you have problems. So
So in parallel, naturally the cells will want to charge each other. So the lowest one will bring the rest down as they dump,
that's right.
the energy into the other one. So, we didn't want this guy at 3.9, this guy at 4.2, this one at 4.3. We didn't want
That's right.
overcharge.
Well,
So,
you lose energy efficiency
Correct.
as well, so
Right.
that's bad.
so we followed up with the balance charger after bulk charging.
Well, that's fantastic. I want to thank you guys for spending time with us, and I would love to go see a race. In fact, the next time y'all race, let us know.
Right.
We're definitely going to go to the racetrack and we'll watch these guys in action and root them on. Okay? All right, gang, that's it for another episode of The Energy Hunter. Make sure to stay tuned next month as we come out with a new episode and new energy adventures. See you next time. Okay, today, so that's to the students and having them blah, 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 blah. But that is a fantastic amount. Okay. I'm in. Now the seat belt is a 5-point seat belt, they told me. There ain't no way. Get out of here. Oh, and I just broke their